most of you did get the right answer. The center is 5, -8, and the radius is, oh, wow. I wrote the wrong equation. Sorry. And the radius is 3. So the third answer was the correct answer, which the majority of you certainly selected. But I have another poll as well. Sure. I don't need to share the results. Close this. Yeah. Can I end poll? So I had another poll, which I've kind of just gotten used to trying out using these polls, but it seems like I can't launch it, which is annoying. Oh, there it is. So there is, so I was asking you a question. Can you guys see what I've written? And I feel like my third answer isn't really apt, but you can answer via a poll. So can you guys see this all right?
Yes.
Yes.
Cool. Yeah, I mean, yes, the poll results seem to speak to it. Good. Yesterday I was having some blurry issues. I think it was because I might not have downloaded the most recent version of Zoom or updated Zoom. So good. I'm glad everyone can see because that's important. All right, let's end the poll. Great. Let's close the poll. So for a circle, the way you find the center of a circle, the way I usually find the center of a circle is I think about the values of x and y that make each of these 0. So if x is 5 and y is -8, then that's 0 and that's 0. I want to point out, and I think Dr. Thompson said this in her lecture notes, the center is actually not part of the circle, right? Like it's an important point, but it's not a point on the circle, right? It's in the middle. And we can see that because it doesn't actually solve the equation, right? If you plug in 5 for x and -8 for y, you get 0 plus 0, which doesn't equal 9. So it is an important point, but it's not a point on the circle. And then the radius, if the equation is written in this standard way, the radius is the square root of that number, which in this case happens to be 3. Really, it's coming from the distance formula, right? What's actually happening here is we're saying that this circle, which is centered at 5, 8, sorry, 5, -8, and has a radius of 3, any point here, x, y, what you're really just doing is you're using the distance formula to say that the distance between this point on the circle and this point, which is the center, is always going to be 3. And the distance is the square root of the difference in the x's plus squared plus the difference in the y's, so y minus -8. And it's equal to the distance, which is 3. And then we square both sides and we get x minus 5 squared plus, I'm going to simplify this as y plus 8 squared equal to the distance squared. So really the equation of a circle is just coming from saying that all of these points on the circle are the same distance, the radius, away from the center, and then squaring both sides of that distance equation to get the equation of the circle. That's it. All right, so I will try to think of a poll question for Thursday that seems pertinent, but I'm still getting used to using the polls because I didn't do it last quarter because it seemed overwhelming. But we will try out some polls and see how they work. It also feels like a good way to start class because often people are kind of waiting around. Ooh, is that thank you, Alyssa. Everyone cheers to Alyssa. Awesome. That's great. Appreciate it. So I'm going to go through these problem solving problems. If you have questions, don't hesitate to ask. Let me make sure the only problem I have, and it's not a big problem, is whenever I'm looking at myself on the screen, like my head's just kind of cut off. I'm like, oh, that doesn't seem great. So try to get the whole board in there and most of my head, so I don't feel like I'm just looking at like nose down. It's really, yeah, it's not great. So yeah, find the equation of the line passing through these 2 points. So the equation of the line passing through the points -2, 5 and 4, 1. So for the equation of a line, and this is generally, right, for any time trying to find the equation of a line, you need two things. Now, the applied addition, I didn't know there was an applied addition. Interesting. Oh, it does say an applied. Interesting. Okay. Well, I'll take a look at it and see if it looks like it's the same as the other one after class sometime. Okay. Oh, well. Such is life. We'll get it figured out. Someone will find something eventually. So, to find the equation of a line, we need two things. We need a point and we need a slope. We've got a point. Actually, we've got 2 points. So we've got a point covered, but we need a slope. And the way we find the slope is by using the slope formula or the slope equation. The slope between 2 points is the difference in the y's over the difference in the x's. So the slope, which we usually use the letter m for, is given by the difference in the y's, so y2 minus y1, over the difference in the x's in the same direction, x2 minus x1. So I can think of this as x1, y1, and this is x2, y2, or this is x2, y2, and this is x1, y1. Basically, the order you subtract the y's has to be the same order you subtract the x's. So I can either do this as 1 minus 5 over 4 minus negative 2, or I could do it as 5 minus 1 over negative 2 minus 4. Probably the number one mistake people make doing this is doing the x's on top because they see the first thing are the x's and they subtract those first. So just be careful that it's always the y's on top, x's on the bottom. It's rise over run, which is the change in height, which is the change in y, over the change in run, which is the change in x. So that's going to be, so here it would be, right, it's either going to be negative 4 over positive 6 or positive 4 over negative 6, which are the same, right? Negative over positive is negative. This is going to be negative 2/3. There's your slope. And then to find the equation, there's probably like, there's 2 different ways you can do it. One way is to do it as y equals m x plus b, and then plug in either one of these points to figure out what the value of b is. So you can say y equals negative 2/3. I'm going to plug in, I'm going to pick the positive x value because it seems easier. Negative 2/3. Oh, but I have to plug in for x and for y. So x is going to be 4. Y is going to be 1. And then I'm going to solve for b. So I've got 1 equal to negative 2/3 times 4 is negative 8/3 plus b. I'm going to add 8/3 to both sides. And 1, which is 3/3, plus 8/3 is 11/3. So 11/3 is equal to b. So then my equation is going to be y equals negative 2/3 x plus 11/3. Alternatively, you can also instead use the, so this is called the point slope version of the equation of a line. There's also the, or sorry, this is the, sorry, not point slope, this is slope intercept, where you can automatically see the slope and the y-intercept. There's also the point slope form, which is y minus the y coordinate equal to the slope times x minus the x coordinate. And then you plug in a corresponding x and y value and the slope. So I could say y minus, you can pick the same point or use the other point, doesn't matter. You can use any point that's on the line. Y minus 1 equals negative 2/3 times x minus 4. Some people are totally cool with you leaving it this way, which is fine, right? If someone says they're fine with you leaving it this way, you just leave it this way, right? There's usually no good reason to do more work, which opens up the opportunity to make errors. But if they say they want you to write it this way, which is often the case, then we have to then solve for y. So we're going to get y equal to, I'm going to distribute the negative 2/3. So I'm going to get negative 2/3 x. Negative 2/3 times negative 4 is positive 8/3. And then I'm going to add this 1 over as well. And we can see, oh yeah, that's the same. That's negative 2/3 x plus 8/3 plus 3/3 is 11/3. So either way you want to do it, you should get to the same answer. There was something else I feel like I wanted to say here. It's not coming to me, which is all right. There really was something else I wanted to say. Oh well, that's life. Sometimes you don't remember all the things you want to say. Yeah. All right. Oh, I know what it was. The reason you would want to write it this way, so there is a good reason writing it this way, in that this way you're writing y as a function of x, where you explicitly have y in terms of x, whereas this way it's not really writing y as a function of x. So that's why people often default to this. Also, this is unique, right? There's only one way to write the equation of a line in the slope-intercept form, whereas there are many, many, many infinite number of ways of writing the equation of a line in the point-slope form. So this is often defaulted to as well, because there's only one way to do it this way. All right, let's look at the next question, which is to find the equation of a circle with the diameter to the same points. Cool. So same points, which were -2 and 5 and 4 and 1. So now we're trying to find the equation of a circle that has these 2 points at the end of a diameter. So you don't have to draw a picture, but I kind of like drawing a picture. So I'm thinking of this as, okay, maybe over here is -2, 5, and over here is 4, 1. And I'm trying to find the equation of the circle. So to find the equation of a circle, we need 2 things, right? We need a center and a radius. So the center is going to be the midpoint. Of these 2 points. Here's the really nice thing about a midpoint. The midpoint of 2 points is just the average of those 2 points, right? So if you're trying to find the middle of 2 things, you're really just trying to find the average of 2 of those 2 things. And we know how to take the average of 2 things. We just add them together and divide by 2. So I'm going to take the average of the x's, which is going to be -2 plus 4 divided by 2. I'm going to take the average of the y's, which is going to be 5 plus 1 divided by 2. And we're going to get, see, -2 plus 4 is 2 over 2 is 1, and 6 over 2 is 3. So there's our center. And then we need to find the radius. So the radius, as we already kind of know, is the distance between the center and any point on the circle. I'm going to use this point because it seems easier, but we could also use this point. So the radius is just going to be the distance between these 2 points. So the distance is going to be the square root of 4 minus 1 squared plus 1 minus 3 squared. That's going to be the square root of, let's see, 3 squared plus -2 squared, which is going to be the square root of 9 plus 4, which is 13. So then we have to write the equation. So we know that the equation of a circle is x minus the x coordinate squared plus y minus the y coordinate squared equal to the radius squared. So here it's going to be x minus 1 squared plus y minus 3 squared equal to this number squared, which is just 13. Right? We could write the square root of 13 squared, but we should really just write 13. So if we know the center and the radius of a circle, we know how to find the equation of the circle. There are other ways of writing the equation of a circle. This is kind of the standard way of writing it. Actually, not kind of, it is literally the standard way of writing the equation of a circle. That said, there are other ways of writing the equation of the circle, like in this next problem. Again, please do stop me if you have questions, or write something in the chat like, hey, James, what about this? Not that I expect people to have questions necessarily. Right? Most of this is intended as a review of stuff you should have seen in a pre-calculus class. But I know that not everybody gets the same pre-calculus experience. So if you have questions, that's what we're here for.
Can you show the end of that last problem really quick? I didn't get it.
Totally. So we found the center, we found the radius, and then we're essentially using the general or the standard form of an equation of a circle, which is that if you know the center is a point, like, so if we know the center is HK and the radius is R, then the equation is x minus the x coordinate squared plus y minus the y coordinate squared equal to the radius squared. So that's what we did. We did x minus our x coordinate squared plus y minus our y coordinate of the center squared equal to the radius squared.
Thank you so much.
You're very welcome. Yeah, I'm always happy to clarify things if you guys have questions.
A quick question, James.
Yeah.
So for when you found the radius, use the center of the circle and then just to pick a point?
Well, any point that's on the circle, which we were given two of.
Okay, so it could have been the two endpoints or one midpoint in the center?
Well, so actually, that's a good question. So you could either find the radius. There's actually three ways you can find the radius here. You could do the distance between these 2 points. You can do the distance between these 2 points, which would also give you the square root of 13. All right, let me just check that real quick. It would be the square root of 1 minus negative 2 squared plus 3 minus 5 squared, which would be the square root of 3 squared plus negative 2 squared, which is still the square root of 13. Or, so I recommend doing it one of these two ways, but a third option would be to find the distance between the two endpoints of the diameter, which would end up being the square root of 52, and then dividing that in half, which would give you the square root of 52 over 2, which is the same as the square root of 13. So that's a third option, is finding the distance between the endpoints and then cutting it in half.
Thank you.
You're welcome. But sometimes equations of circles are not written in the nice standard way where you can easily see the center and the radius. Like in this next example, here is a circle, or I should say, here's the equation of a circle. 2x squared plus 2y squared plus 10x minus 6y plus 1 equal to 0. Right, okay. So this is the equation of a circle. And the way you typically can identify that you have the equation of a circle is that you have both an x squared and a y squared, and they have the same coefficient, in this case 2, and the same sign. So it's a positive 2x squared and a positive 2y squared. If those are your highest powers of x and y, and the only other things you have are x and y to the first and a constant, that will always be a circle. Yeah. So I want to find the center and the radius. And the way we're going to do that is by making this equation of the circle look like the standard equation of the circle. First and foremost, I don't want those coefficients, or I should say really, I want x squared and y squared to have a coefficient that's 1. So I'm actually going to do 2 things at once. I'm going to, well, not once. First off, I'm going to bring this constant term over to the other side. Everything else is going to stay here though. So I'm going to rewrite this as 2x squared plus 2y squared plus 10x minus 6y equals negative 1. And then I'm going to divide everything by 2 because I don't want those coefficients. So I'm going to have x squared plus y squared plus 5x minus 3y equal to negative 1/2. Right? We do have to divide everything by 2 if we're dividing by 2. And then we're going to group the x things and the y things together. I'm going to write it in a very suggestive way here. I'm going to have x squared plus 5x. I'm going to leave myself a little space here because what we're about to do. And then I'm going to have a y squared minus 3y. And a little space there as well, equal to negative 1/2. And what we're going to do to be able to write this in the same sort of way that this equation is written in is we're going to do what's called completing the square, where we're going to take the coefficient of x, divide it in half. So we're going to get 5 halves. And then we're going to square it. And that's going to go up here. So 5/2 squared is 25/4. So I'm going to add a 25/4. I'm also going to throw this pen away because it feels like, oh no, I forgot to have refills. I'm going to refill it with a new cartridge. If I add something on the left side of an equation, I have to also add it on the right side of the equation. Same deal here. I'm going to take this coefficient, which is -3. I'm going to divide it in half, and I'm going to square it. And that's what's going to go up here. So I'm going to add a positive 9/4. If I add it here, I have to add it over here. Okay, so here's how this ends up playing out. This whole thing, x squared plus 5x plus 25/4 factors. It factors as x plus 5/2 squared. Right? If you multiply this out, the 5/2 times 5/2 gives you the 25/4, and the 5/2 x plus the other 5/2 x gives you 5x. You don't have to think about that because you can always just say whatever this number here is, this 5/2, that's what's going to go right there. Similarly, this y squared minus 3y plus 9/4 is going to factor as y minus 3/2 squared, which is why it's important to think about what the sign is there. And then on the right-hand side, sorry, not plus, equals, I've got, let's see, 25/4 plus 9/4 is 34/4, which is 17/2, minus 1/2 is 16/2, which is 8. And now we've written this in a way where we can see all the things. The center is the coordinates that make each of these parts 0. So x is going to be -5/2, y is going to be +3/2. And the radius is not a particularly nice number, but it is a number. The radius is the square root of that, which is the square root of 8, which you could rewrite as 2√2. Either way is probably fine. I will say, generally, if you're asked to find a radius and it's not a nice, right, integer number, you shouldn't get a decimal approximation unless you're specifically asked to. So if you have, the radius is square root of 8, you should leave it as square root of 8 when you're like typing it into WebAssign or WebAssist, whichever one you guys are using. Right, you should not write the decimal approximation, which is like, I think it's like 2.8 something. So right, leave it as square root of 8, not 2.8, unless someone says to give a decimal approximation. All right. Let's see, we end at 10:20. Yes, we end at 10:20. Okay. Also, I want to say, so if there are things you think you want to see in class on Thursday, you're welcome to shoot me an email. Email is probably best. Just saying, hey, James, can we talk about this topic on Thursday? Or James, I was having trouble with this specific question. Can we go over it on Thursday? Or you can put it in discussion, right? There are many, many ways to let me know what you want to see if there are things that are like, I really need help with this. All right, let's look at
Hey, James.
Yeah, go ahead.
I don't know if you're familiar with web work, but if you are, when we type in our answer, should we type it in, like for the last one, as square root of 8 or 2 square root 2?
Either way,
I know like it's pretty tricky. Okay, thank you.
Either way should get accepted as correct. Usually typically web work is pretty okay with you not simplifying things. Not that I consider either one of those really more simplified than the other, but generally, like if you left an answer in a very like if you said, if your answer happened to be like, if your answer was 8 and you wrote 2 + 6 as your answer, I think it would still come up as correct. So I would definitely encourage you to play around with it, but also only if you have, right, like I know you only get a certain number of attempts for things. So if you have lots of attempts, you might want to kind of see how things are working. But yes, that's something definitely, especially in office hours, when people have questions, it's often about how to make it, like we know what the answer is, but we're having trouble making web work see that we have it. And oftentimes, sometimes it's that something's not capitalized. Sometimes it's that we're reading the question just slightly wrong. So I will encourage everyone to really pay close attention to the phrasings of questions in web work in general, and kind of just making sure you know what's being asked for. But we can definitely, office hours is probably a better place to look at that, but yeah, I'll take a look too, because once, hopefully I'll get access to Dr. Wynn's class and I can kind of look at what her web work questions are. Yeah. All right. It can be picky though, for sure. I'm going to skip question 4 for now because I think it might be more useful for us to look at question 5. So let's talk about domain. So domain of the following functions. I'm actually going to, I'm going to, no, we only got it. Yeah. Let's look at that first one. F of x equals the square root of x plus 5. So when we're trying to find the domain of a function, you're really just trying to find all of the values that x is allowed to be. And there are typically 3 types of restrictions. This one is, well, for a function, we know we're not allowed to take the square root of what kind of number? Of a negative number. Now I should say that's not entirely true, but you can take a square root of a negative and get an imaginary result or a complex result. But when someone says a function, what they're saying without saying these words is they're saying it's a real valued function, meaning the outputs, the things that the function is equal to, all have to be real, non-imaginary numbers. So we're talking about the domain, we're talking about all the things you can input so the output is real. So we can't take the square root of a negative, which means we're going to set the insides of the square root, or the argument of the square root, in this case x plus 5, to be greater than or equal to 0. Because it is perfectly fine to take the square root of 0. Excuse me, square root of 0 is 0. So then we, in this case, since it's a linear term over here, we can just solve for x. I can subtract 5 from both sides and get x is greater than or equal to negative 5. Now, there are usually, I would say there's 2 typical ways people want you to write the domain of a function. The way that I am most partial to is writing it as an interval notation. So here the domain, we could write as, and we can even draw it on the number line if we want. So here's negative 5, and I want x to be bigger than or equal to negative 5, which means we're to the right of negative 5, including negative 5. So I want all of this. So I can write that using interval notation. That's going to be bracket negative 5, because I want to include the negative 5. And then everything to the right, meaning everything to infinity. We don't put a bracket on infinity because it's not a real number, so we can't actually include it. We're just saying we want everything up to infinity, everything that is less than infinity and bigger than or equal to negative 5. There's also another way sometimes teachers have you guys write them, but it's usually less used. It's called the set builder notation, where you basically just say, I want the set containing all x values such that, and then you just write the condition that you found right here. X is greater than or equal to negative 5. To me, this is less explicit, right? I feel like this doesn't actually show us as much, but depending on how your teacher says it, they might want you to write this way. I would venture a guess that both of your teachers will probably ask you to write domains and ranges using interval notation like this, but it's possible they might ask you to do it like this. Let's talk about the 2 other domain things, because that's something we can definitely fit in these last 3 minutes here. So how about the domain of f of x equal to, sure, let's keep it real simple. 6 over x plus 5. So in this previous problem, you can't take the square root of a negative. So the insides had to be non-negative, aka 0 or positive. While as here, it's perfectly okay to divide by a negative number. What is it not okay to divide by? Right. Can't divide by 0, right? Totally undefined. Not even that we get imaginary numbers kind of way. It's a kind of things blow up and get infinitely or negatively infinitely large. So we definitely can't divide by 0. So what we're going to do is we're going to set, actually, I usually kind of say it this way. We want to exclude. So I don't like saying like, I find it annoying to have to write x plus 5 is not equal to 0. I like to say we're going to exclude where the denominator is equal to 0. In this case, it's going to be where x is equal to -5. So domain here is going to be everything except for -5. So in this case, if we're looking at the number line, there's -5, and that's literally the only thing we don't want. I want all of this, I want all of this. So here our domain is going to be everything except for -5. So everything from -infinity to -5 with a parentheses to exclude -5, union everything from -5 to +infinity. So when you don't want a thing, you put parentheses next to it to indicate that we want everything up to but not including that point. And then lastly, I should say, the third type of function that has a domain restriction is a logarithm. So if I wanted to find, say, the domain of f of x equal to log base 3 of x plus 5, just to keep with the x plus 5 theme here. So a logarithm and a square root have very similar but slightly different domain issues. For a square root, the insides have to be positive or 0, because you can take the square root of 0, right? The square root of 0 is 0, because 0 times 0 is 0. And the square root of 1 is 1, because 1 times 1 is 1. And the square root of 9 is 3, because 3 times 3 is 9. But for a logarithm, you can't take a logarithm of 0 or a negative number. So for a logarithm, we have to say that the insides have to be strictly greater than and not equal to 0. So in this case, we're going to get x being strictly greater than -5. Again, we can draw the number line if we want, although it's really not particularly necessary. So here's -5. We don't want -5, but we do want everything to the right of it. So here our domain would be almost the same as this domain, except instead of including the -5, we're going to exclude it with a parentheses. Parentheses, I think that's the singular. We are out of time by -1 minute, so I should stop talking. I will try not to go over. Occasionally, I'm going to go over a minute because I just sometimes get going away and forget what time it is. But if you see me blabbering on and it's like 10:22, you're like, hey, James, you need to stop talking. Yeah, I think that's about it. So Thursday, we'll continue on talking about this pre-calculus review material. If you have things you want to see, let me know. Also, as far as someone asked me the other class, my other class, I'm like, oh yeah, how to address me. You are welcome to call me James.